Hello, everyone, and welcome back to the Moonbuilders Workshop. Happy New Year. It's been a little bit. We are very, very glad to be back. And today we have a very special guest. We have Fig from Squid. Now, Squid and Moonbeam are very closely aligned in our missions in terms of cross-chain connectivity and interoperability. And so to tell you a little bit more about Squid, Squid is a cross-chain liquidity layer. It is powered by Axelar, and it makes it very easy for you as a developer to build applications that are cross-chain, and it facilitates very easy and simple development. So Squid has an API and an SDK and a front-end widget, which you'll learn more about today. And they make it very easy for you to build decentralized and modular and trustless cross-chain logic into your application. So Squid takes away, much of the hard parts of building. It makes it very easy for you to build seamless cross-chain applications. So in this Moonbuilders Workshop, you'll get a complete introduction to Squid's architecture, developer tools, and you'll learn how to build a cross-chain transaction. So we'll go through all those steps, and Fig will show you exactly how that's done. And keep in mind that if you have any questions, you can drop them in the chat. There is an Ask a Question box. There's also a text chat. And I want to give a very special congratulations to the Squid team. They just announced their seed round yesterday, huge milestone. And I'm very happy to congratulate them on that and to be here with this well-timed workshop. So Fig is a co-founder of Squid, Again, the liquidity and messaging router that's built on Axelar. Before working on Squid, Fig worked on Solidity applications, on-chain trading applications, and validator infrastructure. And since late 2020, they've been researching cross-chain security, MEV, and the consensus layer. And their work has been cited in several different crypto publications, including Masari. So with that, Fig, I'm very happy to hand it over to you to get started and tell us more, and then we'll move on to the demo later.
Yeah, thanks so much, Kevin. Hey guys, thanks for being here. My name's Fig. I'm, as Kevin said, one of the co-founders of Squid. I might share my screen. Start now, Kevin. Yeah. All right, cool.
For sure, that'd be great.
Okay.
And hello to everybody in the chat. Hello, Socrates, Roman, Top Rain, Touristy.
All right, can everyone see that?
Perfect.
We're good. Okay. Yes, the goal of this workshop is for you to have an understanding of Squid and how it can benefit you. You should be able to leave the call and be able to add cross-chain to your app super easily. You're going to be able to build a cross-chain transaction, and that's using Squid, and Axelar's powering it under the hood. I'm going to start off just by explaining a little bit about how Squid works, and then get into some code, and we'll show you our widget at the end. And if you have any questions, drop them in the chat, and we'll have a session answering questions later on. So Squid, who are we? We're a small team working alongside Axelar to bring native-to-native cross-chain swaps to their network of chains, and we're distributed across the world. We're just in a Discord server. 8 of us can code, including our amazing designer and branding person who made our brand. And yeah, we launched yesterday, which we're super excited about. So tired, but yeah, we're just super excited to share it with you guys. So what are the key features of Squid? What makes us different? First thing is we're powered by Axelar, which I believe is the most secure generalized cross-chain protocol. It's what helps me sleep at night. We've got single-click flows, which if we're going to compete with Web 2, we're going to need single-click interactions. It's like if there's 2 clicks, a user's going to get lost. A percentage of users are going to get lost every click. And everything Squid does is in 1 click. And contract calls, this is the one I'm most excited about, where not only you have native swaps, but then you can do anything on the other chain, like buying an NFT, you can do staking, you can do anything you can do on a single chain, you should be able to do cross-chain just as easily. And we've got a connection to the Cosmos, which is a the Cosmos is like a community of amazing like cross-chain innovators and developers, and I mean same as the Polkadot ecosystem. So yeah, we're super excited to hopefully be able to connect you guys up with different teams over there and build some interesting cross-chain relationships. Instant execution, this is our magic trick, which we're working on Axelar with, hopefully be live at the end of Q1. And what it means is that, you know, users in cross-chain usually have to wait maybe, you know, half an hour, could be a minute even, is quite a long time for a lot of people. And we're bringing that down so that every interaction with Squid, swaps, NFT purchases, staking, can be done in less than 15 seconds. And it's still falling back to the sort of trustless, decentralized execution, still super safe and censorship free. And lastly, we have this this feature where you can get gas on any chain. So often when a user does a cross-chain, you know, movement or interaction, say they buy an NFT, they're a user of Polygon, you're an NFT platform on Moonbeam, and they can buy the NFT in one click, but then once they get the NFT, they need some gas. And you know, we have faucets around the place, we have gasless transactions, but all of them require an extra step in a lot of cases. And with Squid, we just have a Boolean, like flip a switch, so that every transaction you do with Squid, you can get a little bit of gas, like $1 of glimmer. And so when the user onboards to your platform, they can do more things. They can move around, they can use it again. What's our stack? We've got smart contracts in every chain, including Moonbeam. We've got an API and SDK powered by backend and front-end widget, which you can install. And the smart contracts, they've been audited by Consensus Diligence and Aki blockchain. We've got 4 audits already, and we're having a 5th one next week. And so we've made sure to connect to, like, we've prioritized the chains where we think is the most innovation is going on. And you can see we've got the 2 rollups. We've got obviously mainnet and you guys and a few other EVMs. And then in the Cosmos side, we've got, yeah, as I said, a bunch of amazing innovation. You've got DYDX has moved over there. We've got, yeah, cross-chain lending, cross-chain, a lot of native applications are happening over there. I'm excited to connect that up with the Polkadot ecosystem. So security is often a question that everyone, you know, asks when they first hear cross-chain, and you guys obviously know all about this with the Nomad hack. And the design of Squid is specifically to avoid the security issues with cross-chain. We're powered by Axelar, which I believe is extremely secure, much better than a lot of other protocols out there. But Squid does native-to-native swaps. So when a user uses your application via Squid, we can swap into a native ERC20 token or native Glimmer, and then they can use their application from there. So they don't have to hold a bridged asset to do a cross-chain interaction. It's always native to native. And the way we do this, also a little bit into our architecture, is we're built on generalized message passing, which Axelar powers that. And then we have a smart contract layer on top, which lets you call, you know, Curve, Stellar Swap in other chains, whatever DEX has the best liquidity. And then our backend finds a route through the best price. And that's how our trades work. You can see we bridge Axelar USDC in almost all cases. And what it means is that all the liquidity only has to be concentrated on USDC, which in most chains there's already great liquidity for USDC. We also, you know, we have intermediate assets like Glimmer, which we can swap to get good prices. So with Squid, we don't require necessarily any more liquidity. We just can use like the existing trade routes that are within each chain. So that's a brief overview. I think we might be doing questions at the end. Is that right, Kevin? I think.
Yeah, if that's okay, we can wait till after the demo.
All right, so I'll get into some code now. This is going to be using our SDK, which is an npm package, and you can see there's a QR code on the screen if anyone wants to code along. And this is our examples repo, which has just a few, I'll show you. First example is just the most basic one, how to do a swap. And once we have a swap, you'll be able to extend that. I'll show you that later. So let's go over to VS Code. Let's see. Okay. So if you're in the repo, you can go to the cross-chain swap folder. You'll see there's a few others which I haven't pushed yet. This Buy on Treasure is buying NFTs across chain, which I'm super excited. I did that on Friday, and I think I did it in 25 minutes. I tried to race myself and was able to buy it. Yeah, it's such a thrill to buy an NFT in cross chain. Been saying it for a while. So the cross-chain swap is the most basic primitive of Squid. First thing you do is you import our SDK, import ethers as well. This is just for signing transactions. I've got env set up, so if you copy the env example and put your private key in there, it shouldn't get pushed to GitHub. Should be secure, but you guys should be really careful, obviously. So we set up the private keys in the RPC. We've got, so we use chain IDs, which is a standard for the EVM chains. You guys know that, I'm sure. And so we're going to do a swap from Avalanche to Polygon. So we've got config in here. In Squid, we use this sort of this E address, which represents native tokens, and that's because native tokens, they don't have an address necessarily. So on Celo, which is one of our connected chains, it does have an address, but in most cases, we just use this E address. And we're going to use the DAI on Polygon. I should have set this to do Moonbeam for the example, but you guys can put Moonbeam's details in. This is the amount. So this is in Gwei, and so we've got this function to set up the SDK, which is going to be used later on. The base URL is actually it's 0x Squid, and we just change Squid router, so you can hit that one too in the repo. So first thing, set up provider and the signer, and initiate the SDK using that function. And here we go. This is the swap. So the parameters of the swap are what you'd expect: to address, which is the receiver on the destination chain, from chain, from token, and then from amount, how much you're sending, to chain, to token, and then slippage. And that's all you need. And you'll get a quote back, which is in this route object. And all you need to do to execute the route is use squid.execute route. You send the signer in and the route in, and we'll wait for the response. And we have, fortunately with Axelar, we have this amazing block explorer, which makes development much easier. I can show it to you quickly, actually. Let's see. So for example, you can see all the transactions happening on Axelar at the moment, and go into one of them. So it's when you submit on the source chain, you got the source transaction, which in this case is on Avalanche, and we've got the Avalanche details. This looks like a Squid swap happening. Hopefully on our app, which is super exciting. And there you go, the Squid router. And then you'll see it's executed on the destination chain Polygon. Also, there's a refund which will happen automatically. I can talk to you about gas briefly. So we handle all the gas payments in the Squid SDK. So this route object will return a value which takes care of paying a cross-chain relayer. And we have a small buffer, like a 50% buffer of gas, so that if the gas prices spike by 50%, you still get execution. And if they don't spike by 50%, that's what this refund is. So hopefully this user is going to, the Axelar relay does this all automatically. They'll eventually get refunded their gas, which in this case is only 20 cents probably or something, because it's Avalanche Polygon, but we have this set up so it scales to any gas cost. Okay, so that's a basic swap. Once you have the swap working, we can do a deposit to Cosmos as well, which is essentially just a swap from any EVM chain into the Cosmos. But a lot of Cosmos applications, they want access to users from other ecosystems, and if you can build a relationship with a Cosmos application and try and get like users from the EVM world moving over there, then I think it's going to be good for both parties. It's not just a one-way street. And I've got an example for that in Cosmos. The only difference here is that you've got a different address type with Cosmos. So in the end, we've got the Osmosis recipient address, which is, they can't send to the same address that they have on Ethereum in this case. So you're going to need them to either log in with a wallet which has both Ethereum and EVM and Cosmos addresses or capability, or you're going to need them to download their Cosmos app, download a Cosmos app and put that in. And so it's exactly the same code here, except we replace the Osmosis address in, and then the Osmosis ID as well. So a list of IDs are in our docs. In this case, Osmosis is Osmosis 1, and that's because Cosmos has a slightly different chain ID system to the EVM world. And so you can run that one. And then finally, the most exciting thing is, like, once you've got swaps going, it should be very easy. You guys can just set that up quickly. We can extend it to anything. So we can call a contract on any chain using the tokens from the swap, and it's all still in one click. I'm going to use staking as an example into Moonwell, and just open it up. We've got stake on Moonbeam. Here we go. There's a Moonbeam example. Okay, so bulk of this is all the same. We're importing the ABI of Moonwell though, and then I'll show you what we do with it later. We also have the address of the staked token, and we're going to need that later on as well. And same as usual. And here we go. So this is a function now where we're going to generate the encoded data for a staking transaction. So the first thing to do is just instantiate the Moonwell interface. I'm going to use the ABI for that, and we're going to encode the function data for Mint, and Mint on Moonwell. Moonwell is, I'm sure you guys all know, but it's a lending platform where you can provide Glimmer, and you can get an interest rate on it. And the Mint function is when you're sending Glimmer into the contract, and you're going to receive a token in return, which represents your staked Glimmer. And so the function for that is Mint. It's extremely simple in this case because the Mint function doesn't actually take any arguments. It's just you call Mint and you send it a value, send it some Glimmer, and you get your staked Glimmer in return, your M Glimmer. But if this was anything else, if this was a transfer, for example, which is the next one, you're going to need to call the function and then also put in the the params for the function. So we've got two things here. We've got the Mint function, and we've got an ERC20 transfer, and this transfer is transferring the minted Glimmer to the user. So I'll go into the flow in a little bit. So we've got the params here are just the user is going to send some native Avalanche to Moonbeam, and they're going to get native, and they're going to get Glimmer, and the slippage is 1%. And if they include this optional contract calls parameter, then our backend will alter the call data on the destination chain so that the swap doesn't go to the user. It actually goes and sits on our multi-call contract where you can use it in any way you like. And so this array of calls is what you will get executed at our multi-call. And so the flow here is very simple. Like you have AVAX, you send it to Glimmer on our multi-call, and then you're going to stake, and then you're going to send it to the user. The first one is the staking transaction, and this is sort of our data structure for commanding the multi-call to do things. And in this first call, it's very simple. We want to send some value to a contract. We want to call the mint function, and I think that's all. And obviously, we need to tell how much gas that's going to cost. So first thing is the call type is 2, and you can see in our docs that the second call type is sending the full balance of native tokens to the address. So the trick here is that when you're doing a cross-chain swap, we don't know what the slippage is going to be when you buy Glimmer from AVAX in advance. It's non-deterministic. So we needed to build a smart contract function where we could use the full balance of the multi-call in whatever function call we're doing. So in this case, we're just going to use the full balance. And you can see the value here is 0. So the value, this is the same as Ether's value, where the value is the amount of native tokens sent in a transaction. And we've set it to 0 here because it's going to get replaced by our multi-call. So we don't want any errors. Like we don't want to accidentally just send one Glimmer and leave 2 Glimmer on the multi-call. We want to send we want it to use every single bit of Glimmer that was received from the swap. So call type 2 will, when it arrives at Moonbeam, the smart contract will replace this value with the full balance of Glimmer, and then we're going to call this mint function that we encoded before. And the payload in this case is unused, so we just send in dummy values. Estimated gas here, this is up to you guys because we can't. We could, but we're going to leave it to the integrator we could estimate the gas ourselves in our backend, but we'll leave it to the integrator to decide how much gas should be spent by this transaction. And you can do that just by running I'd probably recommend running a cross-chain transaction once with a high gas limit. Set this to a really high value and see how much it uses, and then just put the amount of gas that you think the staking transaction specifically will use. So likely it's much less than 250K that I've sort of overestimated here. And then, so what's happened is we've minted mGlimmer. We've got mGlimmer on the multi-call, and now we need to send the mGlimmer to the user before the transaction finishes. Otherwise, the mGlimmer would sit on our multi-call, and technically anyone would be able to go in and send it to themselves from the multi-call address because it's public. So next call is the ERC20 transfer. So it's just call data over an ERC20 transfer, which we encoded before. In here, the target is the ERC20 address of mGlimmer, and the value is 0 because there's no Glimmer being sent around in this transaction. Call type is 1 because this uses the full ERC20 balance. So when you have an ERC20 transaction, we do the same thing where you use the exact output of the swap or of the call that you've done before. And so what's happening here in the payload is we replace the call data of this ERC20 transfer. You see I've set it to 0, the amount that we're sending, to the full balance of Moonwell Glimmer. So this is going to set the input position is 1, so index is 1 here. So it's like sender address is the first argument at index 0, and this is the second argument at index 1. So that is going to get replaced. It's going to replace the argument at 1, and this is the address of the ERC20 contract. It's going to use the full balance of mGlimmer to be replaced into the argument there. and estimated gas fee is 50,000, which is also probably an overestimation. So yeah, that's how you do a cross-chain transaction with Squid. And so you can see it's just a swap, and then you essentially just run a set of calls which you want executed by our contracts, and you can build them however you like. These call types, I'm actually extending the SDK so that you may not have to deal with them in all cases. We just have a function which is squid.build transaction, and we'll have full balance of ERC20 transfer or full native transfer. So it'll get a bit easier over time, but basically we can use the full balance of native, full balance of ERC20, or we can not change the call data at all, which is, when you're buying an NFT, you want to spend exactly the amount the NFT costs. You don't want to use the full balance. So that's call type 0 in that case. Okay, so yeah, I would love to collaborate with anyone who wants to do any of these things with our SDK. And buying an NFT across chain is, obvious use case, really cool. Means if you've got an NFT that any NFT platform, or you're wanting to mint, even anyone with a crypto wallet, with an EVM wallet can do that in one click now. Staking into LPs, so that's not just staking into a contract with one token, but actually doing a trade into 2 tokens and then depositing them. That's like cross-chain zapping. GameFi, letting users who play games move between chains, or access your app from anywhere. And then chain agnostic wallets are, I think, going to be extremely exciting. If anyone's building a wallet or working with a wallet, then we're going to hopefully have this user experience where you won't even need to switch network. You'll have private keys on different chains. You have a Polkadot like wallet, you have an EVM one, you have a Cosmos one, and Squid can power the movement of tokens between all the addresses on these wallets. All right, so I'm going to show you about the widget just very briefly. This is, I might actually show you the front end for a little bit of a break from code. We're so happy with this widget. We've got, this is the front end which just went live yesterday. You can see we've limited our chains just for launch, where we've got a bunch of ones which will probably open up in the next few days, maybe in a week or so. You can go from any token on any of those chains to any token on any other chain. It's like a full any-to-any relationship. And yeah, we give you, it's designed to be used by DEXs. And so we have all the full quote details. And if you have an app on Moonbeam, you want people to onboard into your application or onboard into Moonbeam and do it extremely quickly without much dev work, this is probably the best way. You just put this widget in your app, or you link to it. Stellar Swap are, I think, releasing their version of this in a couple of days, hopefully as well. And so we have this widget studio, which allows you to customize the widget, which is so much fun. You can change your branding in there, same as usual. And we have the docs for that to integrate it here. It's just an npm package. It's a React component that you can put in, and we have an iframe as well. You can see if you use the customizer, you can get the iframe for that specific customizer config or the React snippet, and copy paste it in there. And yeah, that's all. Thanks so much for listening, guys. Take some questions.
Amazing, Fig. I have a couple of follow-up questions just about the demo with Moonwell, if that's okay.
Yeah, for sure.
Okay, sweet. So for the different types of contract calls, like type 0, type 1, type 2, is that all documented on Squid docs?
Yeah, you'll be able to find it on our docs. Yeah.
Cool. So
the docs are docs.squidrouter.com.
And regarding the subsequent interactions, so after the initial swap, let's say that a Moonwell, let's say for instance that they like the contracts were paused or something. Is there a scenario where the initial cross-chain swap is successful, but then the follow-up reverts or something like that? Is there a scenario where that could happen?
Yeah. So you mean if the target of, if you were calling Moonwell and Moonwell was paused,
Exactly.
what would happen? Yeah. We have actually, yeah, we do. So there's a fallback in the contract so that if the multi-core fails, the swapped tokens or the Axelar USDC, which is bridged over, will get sent to the user. So if you have any reversion along the way, the whole thing will revert and the tokens get sent to a fallback address, which we set by default as the recipient address in the SDK.
And that's on the origin chain, or that's on the destination chain?
Destination chain. Yeah.
Cool. Awesome. That's great to hear. I'm going to open up the chat box here, and Socrates has a question. Would it be possible to elaborate on the phrase execution within 15 seconds on most chains, and then 2 minutes decentralized?
Yeah. Okay, sure. So the instant execution, the way it works, essentially when you have a request for a cross-chain transaction happen on the source chain, that's visible to anyone, and the way, so Axelar will start its process of validating it and take 1 to 2 minutes, and what we can do is we've built another contract layer on top, which is where any party, like a market maker of sorts or MEV searcher, can fulfill a transaction on the destination chain immediately. So as soon as they see the request on the source chain, they can loan you, say it's $100 USDC getting bridged, and then it's going to get swapped. They can take the exact payload which was requested to be executed because it's emitted in an event on the source chain, and they can loan you $100, 100 Axelar USDC, execute the exact payload, and then register that with our contract. And then when the bridge transaction comes through 2 minutes later, it first goes through a switch which checks if anyone has already executed this payload for the user. And if they have, then the market maker gets their loan paid back. So the reason it's falling back to decentralized is that if no market maker takes that job, then the swap and the purchase, whatever, will still happen in a minute or 2 minutes. Yeah.
That's very clever. I like it. And the Oyster has a question. When you're doing cross-chain swaps, what liquidity pools are you using?
Yeah, so I mean, we have a router, DEX aggregator essentially, which routes through the best path on every chain, and we're building meta aggregation. So we just find the route with the most liquidity or the best prices, and then give you that route by default. For sure. Amazing. And that's any DEX. We don't have any limitations. It's generalized.
Mm-hmm. So I think you covered this question, but it's a very big deal that you can handle native token transfers, right? And how did you indicate that again? What was the format that you specified?
It's call type 2. So call type 2 is I might change these in the SDK so that you can just literally go call type dot full native balance and then make it easier. But for now, call type 2 grabs the full balance of native. 1 is full balance of ERC20, and 0 just doesn't just executes the call data without any change. Cool.
And a similar question is, let's say you're transferring from one chain where AUSDC, has a specific contract address. Let's say that that's, for example, not the USDC Circle issued variant, but then let's say you're transferring to a chain like Ethereum where it is the Circle issued canonical, USDC.
Yeah. So we essentially, that would just look like a different contract address. You can see if you go to our widget, and in some of the chains, there's 3 different versions of USDC you can buy. And you need to just specify that, find the exact address for the USDC you want, and you'll be able to get that one.
Cool. So it's seamless. It's easy. I mean, there's no Yeah, there's
changes.
no intricacy. It's very easy.
No, yeah, like we've got all the stable swaps, like stable swaps integrated, so it'll swap from Axelar USDC to whatever USDC type you need.
Sweet. So thinking about Axelar, the audience may have already seen a prior workshop with Axelar. They may be a little bit familiar, but for those who aren't, would you mind giving us a quick recap, as to why you chose Axelar and maybe how it facilitates cross-chain swaps and transactions?
Yeah, of course. Maybe I'll share my screen for a second again. I think Axelar scan is probably the best way to really explain Axelar. So I can start at the opening page, which shows you all the networks they're connected to. And so it's a generalized protocol. It's got IBC built in so that it can connect to any chain with IBC. That's why you see all these Cosmos chains. And it has its own generalized protocol called cross-chain gateway protocol, which allows it to connect to any other chain with smart contracts. And so we have EVM chains here, and the way messages moved across with Axelar is that you have a set of validators which are checking if a transaction or an event actually happened on the source chain. And so they need to reach consensus on that. So 2/3 is normal. And then in order to execute or approve a cross-chain transaction on the destination chain is the same thing. There's some threshold cryptography, which happens where you're essentially aggregating signatures of the validators and you're approving a transaction on the destination chain. And you can see like the great thing about Axelar is that it's, there are a lot of cross-chain protocols which claim a similar model, but they're not. To get this to work with a permissionless validator set and a decentralized one is extremely hard because, you have to change the keys, which are, allowed to validate transactions across chain, like all automatically at the consensus level. And that's sort of what Axelar have done. They've got they've got 70 validators already. It's like they're adding more, I think, every week or so. And then I guess the other thing with Axelar is just, their team is insane. They're all amazing developers, and Sergey, the co-founder, and Yorgos, they built the blockchain before. Sergey's worked on internet routing infrastructure. So that's also, from our point of view, we've got, they've built all the right infrastructure for building, reliable cross-chain transactions. So we've got, the routing between all these chains, and they've got the scan, they've got relay, good execution. Yeah, that's my Axelar.
For sure. They're a pleasure to work with. And Socrates has a question here. Do you have any plans to use swap order internalization in the smart contract sitting at Axelar? For example, lending tokens to avoid possibly the last trip to the destination chain. So this is a complex question. So if there's any sort of follow-ups, Socrates may comment or anything.
Yeah. I don't fully understand what he means. I think, so are you, Socrates, maybe answer the follow-up. Are you saying that we want to get the lending token in the swap rather than having to do contract calls on the destination chain? It sounded like you also mentioned something to do with Axelar. I can answer this. It's a general question. So, some people see Squid and they think we're a bridging protocol. And so you can potentially, another way of getting mGlimmer on every chain would be to bridge it to every other chain. And then so we can, a user could essentially buy bridged mGlimmer on that chain and then bridge it across to Moonbeam where it's native and more secure. But the issue with that is liquidity. So, with liquidity, you want everything to be concentrated in one place, ideally, because you have the biggest pool, you have the least price impact. And so, the Squid model allows all of the mGlimmer liquidity to sit in one place on Moonbeam. And actually, in our case, we don't even need liquidity. All we have is the smart contract. You get a one-to-one swap with Glimmer. So, yeah, we generally sort of recommend against just bridging out to all the other chains. It makes sense to keep it on a single chain.
And in terms of your fee structure, What does that look like?
Yeah, so Squid doesn't charge any fees. We have plans to add a fee in the future, but we're always going to need to be like the best price. We've got sort of luxury of using the best route in all cases, so we're already better prices in a lot of cases. So we may charge a fee in the future, but for now it's just gas fees. So the user Axelar doesn't charge any fees on their relaying either. So the user pays exactly what they would have paid on the source and the destination, and then, as I said before, there's the refund where they'll overpay, but they get exactly what they didn't pay for back.
And that best price aspect on the swap, that's a very key point. So you're already offering the best price and the best deal there. So even if there's like a fee added in, you're still getting an amazing deal.
Yeah, we have sorry.
Yeah, sorry.
No, just we have room to move, I guess, and still want the best service.
For sure. And maybe if there's time, and if you wanted to mention anything about what's coming up on your roadmap for 2023, or anything else that you wanted to share with us.
Yeah, sure. So obviously, I'm super excited about this instant execution feature. It's called GMP Express. We think it will make cross-chain, like you'll just flip the switch so that cross-chain is now like as usable as single chain, and we can really start building good user experiences. That's coming up. We're developing like on the Cosmos at the moment to make full swaps into the Cosmos. So right now we don't actually support swaps in Cosmos. We just support swapping any EVM token into a bridged token in Cosmos. So once we have Cosmos to EVM interoperability, I'm extremely excited about that, because I don't know if that has really happened much. We have like cross VM like transactions happening. We've got like ecosystems which have been completely segregated for the first time, like now are really nicely connected. So those are the two ones. And then we'll be expanding our chain set as well. There's going to be Axelar has some really exciting plans to add basically every chain, and we'll be following along as every chain comes. Squid will support them.
Awesome to hear. I was reading through going through all of your docs yesterday, and I just wanted to compliment the team. I mean, all of your docs are very well organized and easy to understand, and uncomplicated. Everything looks for a new user, right? You're trying to get your footing, and it's just like I feel at home going through the docs.
Thank you.
So
that's awesome to hear. That's like docs are the hardest thing, really. We've got put a lot of effort into it.
And so I just wanted to share the link for docs.squidrouter.com. And if anybody has any follow-up questions, I think we still have a couple minutes. But I think we do appear to have covered everything. Oysters on board.
Yeah, oysters down.
Should we share the link to the Discord for anybody who wants to pop in there?
Yeah. I'll grab it. You can follow us on Twitter. Reach out to me for any questions. Happy to help you with code or what you need. Put the Discord link in the chat. We've got Twitter link.
Oh, amazing.
We better put the remember the HTTPS then.
Oh, sure. Oh, amazing. Well, thank you so much, Fig. This was an awesome demo. You explained everything very, very clearly, and I think you got everybody very excited, which we're certainly seeing in the chat. So thank you so much for joining us this morning.
Yeah, thanks so much for having me. It's fun.
And we'll look forward to talking to you in the future. And maybe if you're interested in doing a Moonbuilders Academy course at some point, we could certainly do that.
Yeah, for sure. I'm down. Let's do it.
Thank you so much.
Cool. All right. See you guys.
See you next time.